Hi. In this lecture, we're talking about logic and we're talking about reasoning. Specifically, we're going to be talking about deduction. This isn't going to be the only lecture on logic and reasoning, I'm sorry. And there's some specific things that I want to reinforce before we go any further, things I want you to be able to take away from this lecture. What we're working on is we're working on talking about the logic specifically of an argument. At this point, you should be well aware, right, that arguments have lots of different kind of moving parts. There's the evidence, there's the assumptions, there's the language, and one of those moving parts is the logic. And so we're working on the terminology, the words we use to make precise descriptions of that logic. And what we mean by logic is how an arguer moves from stuff that they know or stuff that everybody knows to the thing that is yet unproven, right? To the thing we want everybody to say, yeah, because these things are true and we know or can believe that they are true, we must then conclude this other thing. Logic is how we get from one to the other. That's what logic is. And the ability to accurately describe an arguer's logic is important, not just because it's what experts are able to do, but if we want to say why is argument A better than argument B, or if we have to choose and we consider all of the arguments for one side and all the arguments for another, on what basis should we go with one or the other, right? Okay, if we want it to be on something other than what I always wanted all along, or my preferences, or what the people in power told me to do, right? If those are our reasons, then we could have skipped the whole argument and gone right to the end, right? But if we're going to base our decisions on argument, we want to genuinely know which argument is better. So the ability to describe arguments with precision sets up and enables us to then make evaluations of argument with precision, right? So, okay. All right. Now, you're going to need to read chapter 6 in your textbook, okay? Like, this lecture does not substitute for chapter 6. Hopefully, what you're going to get from this lecture is a little bit of the nuance, a little bit of the clarification, maybe just hitting it from a different kind of perspective that will give you a better understanding of what you're getting out of chapter 6. It's important that you understand and maybe need to go back and revisit some of the important things we talked about in chapter 4 when we were talking about setting up claims. Logic, especially formal logic, deduction that we're going to be talking about in this lecture, depends on properly worded claims. So if you don't remember what a properly worded claim looks like, right? Quantity and quality, subject term, copula, predicate term, like if that stuff isn't ringing a bell quite right, you're going to want to go back and maybe review that stuff. Maybe go back and look at that lecture again, because if you don't word your claims properly, then doing your formal logic is going to really be hard. So this is some background that you're going to want to remember. Also, we're going to be coming back to the subject of reasoning again in Chapter 7. Chapter 7 talks about, among other things, the different ways or shapes that arguments can take when they're put out in the world by arguers. One of those forms is refutation. And one of the strategies of refutation, we're layering that theory, okay, we're going down. One of those strategies of refutation involves contra-reasoning arguments. And so the better you're able to kind of get a handle on what we're covering in chapter 6, the easier it's going to be to kind of move along and get some of this stuff in chapter 7 as we move through the course. So I just want to put this lecture in context so you know what you're getting out of this. There's going to be other lectures on things like fallacies, and there's going to be other lectures on things like inductive reasoning. So in this lecture, we're focusing really on deduction. This part might be a little repetitive. What is logic? Okay, we've got to answer that question. What is logic? That's our big picture, all right? That's our first theory word, logic, and then we're going to break it into different types because there's different types of logic. We're going to layer down in our theory. Logic means a way of moving, and it's really, that's a metaphor, I understand, but it's really important for you to understand that logic is how we get from one thing to another. It's how we get from what is known to what isn't known, or how we can get to what is agreed upon to what isn't yet agreed upon. Logic is motion. So, all right, for example, if I get up in the morning and I look out my window, right now I am using not logic here, okay? I'm using my senses. I'm intuiting. I'm looking out the window and I see snow on the ground. Now, from my past experience, I have this abstract, vague understanding that I don't really feel like I need to explain, right? Which is that snow is cold, okay? Now, I know that. Now, is it possible that there is such a thing as hot snow? What do I know? I'm not a scientist, right? This is one of my assumptions about the world. So notice I look out the window and there's two different things that are working here, all right? Okay, then when I say no, there's things that come to me through my empirical senses, right? Things I can see, and there are assumptions about the world, okay? Now, I look out the window, I see snow on the ground, and I think to myself, I need to put a coat on, right? Now, why do I need to put a coat on? Because it is cold outside. Now, I can't know that for certain because I am not outside. I'm not looking at a thermometer. I have no reliable reports of fact from outside, okay? I am standing inside looking at my window and I see snow, and my past experience leads me to think that it is reasonable to assume that where there is snow, there is cold. Therefore, I conclude that it is cold outside. Now, among all of these things that we're talking about here, and I want to make this clear, I'm going to pull up my writing stick on the board here, of all of these things, okay? These things over here, okay? Those things are not logic, okay? Nor is this, okay? That is also not logic. We call these things over here, the stuff that we already know, we call those things premises. And we call this one here, all right, the one that we don't yet know, the thing that we're trying to get everybody to accept as true when we're arguers, right? The thing the audience must decide whether or not they're going to accept it as true or false. That one we call the conclusion. So these are premises, and these are conclusions. And none of those things is logic, okay? None of those things is logic, okay? Logic, where logic is right there, okay? Logic is that in between. It's the motion, and that makes it incredibly challenging to describe, okay? So, known. When we say something is known, what do we mean? When we say it's known, that's going to consist of several things. Now, the first and most obvious things that we mean when we say things that are known, we mean facts or reliable reports of facts, and we mean assumptions. And in particular here, we're talking about those assumptions about the real, the possible, and the good, okay? The other aspect of assumptions about argument, that's going meta here and asking more about logic, right? But these are things that we know, right? I see the snow, that's a report of a fact, first person report of a fact, and I believe snow is cold, right? Okay, an assumption about what is real. Now, these are not the only things that fall into known, okay? We also would include things like definitions. If I say this is what a word means, okay, and therefore, right? So if I'm going to define a term, for example, and I want to remember that once we arrive at a conclusion, and we say logically this conclusion makes sense, that conclusion can now become a premise for a further argument, right? I look outside, I see that there's snow. I assume that snow means cold, all right? So I logically conclude that it is cold outside, right? Now, if it is cold outside, right, okay, and I know that if it is cold outside, then I need a coat, then I can conclude that I need a coat, right? Okay, so I just reasoned from things that I knew to something that I didn't yet know, and then I reasoned from that to yet something else, right? So I'm making these kind of subordinate lines of reasoning that allow me to move from, oh, look, there's snow, to I need a coat, right? That's how logic allows me to move from idea to idea, or in a more precise language, from statement to statement, okay? Now, those original known things, those things that we call premises, all right, those things come from a variety of places. And remember, if the premises are in doubt, then the conclusion is also in doubt, all right? Premises and logic logic is good or bad on its own. The premises, if the report of fact is bad, right? If you're accepting a report of fact from an unreliable witness, okay, then that doesn't mean the logic was bad. That means the report of fact was bad. And those are two very different things. Fact claims and movement from fact claim to something else. Those are different, okay? And how we move, that type of motion, can be described in two very distinct ways. Now, we call one of these ways deduction. Deduction is that form of logic wherein if the premises are true, then the conclusion must be true. And that's the idea, right? If the reasons given are true, then 100% absolutely certain, no room for disagreement, the conclusion must be true. Now remember, if, then, okay? Now, this deduction, when we talk about deduction, one way you might try to think about deduction in a way to kind of clarify it in your own head, the way I kind of like to think about it, is that deduction is the logic that is the most like math, okay? If I have 2 apples and I have 2 more apples, then I have a total of 4 apples, right? Now, if I have 3 apples and 2 apples, then no, I don't have 4 apples, okay? If I was wrong, if I thought I had 2 apples in one bag and 2 apples in another, all right, but it turned out I had 3 apples and 2 apples, then no, but the logic is still true. If you have 2 here and if you have 2 there, then you have 4. Not sometime, not under certain circumstances, not depending on the context. 100% of the time, it's like math. It is a rules-driven system, and we'll look a little bit at that as we move forward. Now, the reason we want to make that distinction is because there is another form of logic, okay, wherein if the premises are true, the conclusion is probably true. That absolute guaranteed 100% no doubt about it, the premises are true. If we could get to that kind of level of certainty about anything, it still wouldn't mean that our conclusion is 100% true. It is the logic of probability. We call this logic induction. We're going to have a whole other lecture in induction. In your textbook, these are broken into 2 entirely separate parts. But if deduction is in our head the one that's like math, induction is the one that's like science, okay? And scientists, we're going to learn all about this in a later chapter too, scientists hate saying things with absolute certainty. They like saying things with a sense of probability. Actually, if they're going to disprove something, disproof tends to be lock solid, right? Okay, but proof is always like, well, based on the best evidence, right? So it's always a little bit of that sense of probability. Again, we're going to unpack that concept a lot in another lecture, all right? But suffice it to say for right now that it is not a fair critique of induction to say, well, you don't know that 100% for sure. No, I don't know 100% for sure that if I pick up my coffee cup and turn it upside down over my head, that the coffee will come out. Okay, scientists would say, okay, that's only probably true. Okay, now, all right. Let's move on. Let's focus specifically on deduction, and we'll talk more about induction in that lecture because I think there's some really important things that we're going to want to unpack there. Now, let's just focus on deduction for right now. Deduction is also sometimes called formal logic, okay? One of my favorite questions to ask on a quiz, frankly, right? Okay, which of the following forms of logic is called formal logic? And the answer to that question is deductive logic. Now, it is not called formal logic. The word formal does not mean wearing a tuxedo. It also does not mean rigorous. It does not mean hard, right? There's not formal logic, which follows all these rules, and then informal logic, which is like just easier and simple and doesn't. No, that's not it. They're 2 entirely different kinds of reasoning. What makes formal logic formal is that whether or not it is sound or unsound, valid or invalid, depends on the form. It depends on whether or not the structure of the logic is correct. We could call it formal logic, but we could also call it structural logic, or we could also call it rules-driven logic. If it follows the rules properly, then it is valid. And we want to talk about some of that stuff here in a second, right? But It doesn't matter what the premises are. The premises could be randomly generated. If the premises are true, and if they line up together properly, then the conclusion will always be true. And what makes it always true is because it lines up properly, right? That's your fundamental thing that defines deduction. So the form deductive logic takes is called a syllogism. And if we were students of logic, there's probably 4 or 5 different syllogisms or combinations of syllogisms that I can think of. And an expert in logic, someone that was their main area, could probably come up with quite a few more. But we're going to focus in this lecture on the 3 most common structures or forms of syllogisms, or forms syllogisms can take. But here, I want to just very quickly touch back on chapter 4 and the structure of claims. And I think I may have talked about this in chapter 4, right? But if you don't get your claims structured properly, if you're still loosey-goosey on that, then you could run into some real problems when you try to put together your syllogisms, because syllogisms depend on everything being structured properly. So if you're not using the proper form of is, right? If it's not really a copula, if you're not being clear about all or some of your subject term, if your predicate term is an adjective or an adverb and not a noun, then when you try to put together a syllogism, things are going to start to go sideways, right? Okay, and I can show you some examples, or we can talk about that certainly more when we talk about fallacies. One thing that you can keep in mind is that a properly structured claim should be able to be put into a very symbolic form. And you should know, the more deductive your logic gets, the more it starts looking like math, so the more it starts being more abstract symbols instead of words. And so that is, if you can replace that is with an equal sign, you're probably doing it correctly. And that means that the structure of your claim can look something like that. All X equal Y. All subject term are predicate term. Or, right, remember, we've got the 4 different ways we can do a claim. We've got our particular affirmative, our universal affirmative, or universal negative, and we've got our particular negative. Now, to set up our categorical syllogisms and start talking about our syllogisms, we're going to focus really on just this one. Now, we can do them with all 4. All 4 of them will work in a syllogism, but especially when we're learning, these are the easy ones to do. So let's walk through it. All right, now, couple things about syllogisms. The important thing to remember, if you're going to remember one rule, the rule is the rule of 3, okay? A syllogism must always, not sometimes, not kind of if, but always, 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 rule not a guideline, a syllogism must consist of 3 claims or statements, okay? 3 complete sentences. If there are not 3 sentences, then it is not a properly worded syllogism. There cannot be 2, there cannot be 4, there cannot be 3.1. There must be 3 and only 3 sentences in order for it to be a syllogism. 2 of those premises are going to be called, 2 of those sentences or claims we're going to call premises. And 1 of them we're going to call the conclusion. 3 sentences, 2 of them are called premises, and 1 of them is called the conclusion. Now, there is, in these 3 claims or sentences, there are only 3 different terms. Each of those terms is used twice, and there is only, and each, okay, 3 claims. Each claim includes 2 terms. Each term is used twice. All right, so it's going to look like this, right? Now, in our formula, we have all X are Y. It's got our 3rd term in there, Z, right? There will be 3 terms, and let me show you how this is set up. I will give you an example, right? Okay. So the most basic structure of a syllogism, its simple root kind of form, is called a categorical syllogism. Now, all syllogisms, all forms of syllogisms are just variations of this basic form. This is your core structure. You get the categorical syllogism right, and the rest of them you just begin to see, hopefully, are just kind of like maybe turning them sideways or looking at them from a slightly different angle. So let's walk you through the basics of a categorical syllogism. We start with one premise, right? All X are Y. Going with the universal affirmative in order to keep it simple. All Y are Z. Now, notice I've got two different claims here. Both of these are premises. But there is only, right, three different terms. I've got an X, I've got two Ys, and I've got a Z. Okay, now I have to have one more sentence. We're going to call it the conclusion. And that means I can't use the word Y, or whatever Y is. It cannot be in the conclusion because I've already used it twice, okay? And I have to use X at least once, and I have to use Z at least once. So I have a pretty good idea of what my conclusion is going to look like. But before we get there, all right, remember, our premises, those are things that we know or things that we can agree on, right? These are things that we can see with our eyes or have been reported to us by others in reports we find credible. These are assumptions that we all agree are reasonable. These are definitions that we all can agree upon about what certain terms or things mean. These are other things supported by evidence and logic that we've already established, right? These are the things that we know. And from them, we move, because of the way it is structured, we are able to move to the idea where if we know this is true, and if we know that is true, we can now conclude that this must also be true. Not sometimes, must, right? It is an equal sign. In the way 2 + 2 is always 4, this is an equals. This is going to be true. But only if those are true, okay? Where those two things are in doubt, then our conclusion remains in doubt, okay? And so, right? Our logic, now notice that, okay? Notice that. That's important, okay? Deductive logic, it has that that certainty that it gives us, that mathematical certainty, but it can never actually be stronger than the fact claims that it's based on, okay? I have this report of a fact, but the conclusion that I draw from those credible reports of fact, that conclusion can never be stronger than the fact claims that it's based on. That's just the very nature. The stronger your logic, the more limited its scope. And that's a really important thing to remember about logic. All right, but let's not get there yet. Okay, let me give you a practical example. Okay, some of you think squirrels are cute. Okay, you are mistaken. The reason you are mistaken is because all squirrels are rats, okay? They are the same exact genotype, they eat exactly the same foods, they carry exactly the same diseases, okay? All right, squirrels are rats, okay? They both belong, same exact family. All squirrels are rats. And keep in mind, right, okay, I don't think all rats are out to get us. I'm just saying last time we fought a war with them, they wiped out half of planet Earth, right? So, all rats are vermin, okay? They are spreaders of disease and death, right? Okay, all rats are vermin. Now, you can challenge those claims. You can disagree with me about those claims. You can think, Jim, no, I think that those claims are mistaken. But if the first one is true and if the second one is true, then the third one must be true, okay? At the point where you accept that all squirrels are rats, and if you recognize that rats are, by their very nature, vermin, then you have to conclude that squirrels are also, by their very nature, vermin. Now notice, I've set up my argument here, trying to prove to you that squirrels are terrible little creatures and should be destroyed, right? But I've still only got one term used twice, two terms used twice, three terms used twice. And it's also really, really important that there not be any ambiguity or equivocation. The X that I'm using in the premise has to be exactly the same as the X that's appearing in the conclusion. These two Y's have to be the same y, right? There can't be any ambiguity or equivocation. There can't be a y1, y2. And these two z's, remember, they need to be the same. Any slippage, any difference, okay? You can't tweak the wording a little bit as you move from the premises to the conclusion. Any change is going to upset the logic because it is a formula. It is a fill in the blanks. As long as my x's are the same, as long as my y's are the same, as long as my z's are the same, as long as my equal sign means the same thing, then my formula is going to be correct. The thing about categorical syllogisms is they depend upon that structure. Somewhere else about the truth of the claims or not right now. This is important because when we talk about this structure, we say that if the logic follows this structure, then deductively it is valid logic or valid reasoning. All right, now, people talk about, you cannot say, it makes absolutely no sense to say a syllogism is true or false, okay? That's like saying the square root of 3 is red, all right? Okay, you cannot say it. That doesn't make any sense, all right? Now, you may hear lay people say that. They may also say things like, well, that is a valid fact. No, okay? There cannot be such thing as a valid fact, okay? There is a credible report of fact, okay? There is a fact that we all accept, all right? There is a report of fact that we all accept as true, okay? But validity does not apply to the claims, and truth does not apply to syllogisms or to logic. Claims can be true or false, and the truth of one claim, okay, one claim, true or false. And second claim, we only look at claims one at a time. And that's important, okay? Because a syllogism always consists, remember, of at least 3 claims. And any one of those claims could be true, and any one of those claims could be false, right? Okay, so you can't talk about true applying to 3 things at once. If so, you're committing the fallacy of many questions by trying to talk about 3 claims all at the same time. So we can talk about claims being true or false. We talk about logic, formal logic in particular, being valid or invalid. And we can sometimes use the word sound or unsound. And here's what's important. And this is something that's unique about valid logic. Logic can be valid and a syllogism can be valid even if the claims themselves are all false. Let me see if I can show you an example. So let me see if I can give you an example here of what I mean. Here is a syllogism, and if you look at it, you can break it down if you want to. This is a valid syllogism, and yet the conclusion is absolutely ridiculous, right? Let me say now, first of all, Rook, you've got an X, okay, and in this case, we're talking about the same Lucy, okay? I can't have Lucy being a pig in the first one, and then in the second one, I'm referring to a different Lucy, a Lucy that is a parrot, okay? That would be a violation of the law of identity. All Lucys are Lucy, okay? We have to treat them the same in all cases. If they're true in the what's true about them in the premise must also be true about them in the conclusion, okay? I got 2 Ys, okay? So I've got 2 terms. I've used each of those terms twice. I haven't used either of them 3 times, okay? Same thing. The pig in premise 1 and the pig in premise 2 have to be the same. And then look, all right, now I've got my Z's, right? Again, same thing. My is, are, is, those are all copulas. This is a valid syllogism. Now, none of these statements is true, okay? Lucy is not a pig. Lucy is my dog, okay? And in fact, no pigs are mammals that can fly. That is colloquial, right? Everyone knows that pigs cannot fly. And the conclusion that my dog can fly, what a great wish or dream that might be for me, but it is obviously silly. My dog cannot fly, all right? But the fact that each of these statements is itself as a claim false does not change the fact that structurally this is a valid syllogism because it follows all the rules of a syllogism. All right. Now that we've kind of got this basic structure down pat, and remember, I do want you to make sure you go through chapter 7 in your textbook. There is more to this stuff. You should know, you should be able to identify what a major premise is, a minor premise. You should be able to spot them if given examples. Those are things that are going to show up on your quiz, but there are other forms of syllogism. They follow the same basic rules. We just kind of rearrange them a little bit and tweak them, adding a little here and adjusting a little there. Now, the first and one of the most common variations on the categorical syllogism that you're going to encounter is what's called the hypothetical syllogism. And it's one of the reasons that I think the word hypothetical, sometimes we talk about hypothetical situations and hypothetical in this case, especially when we're talking about logic, hypothetical is almost always, but hypothetical is a contingent major premise. Okay, usually the first premise expressed, not always the first premise expressed, but we have a contingent major premise. And by contingent, we mean we have an antecedent and a consequent. There has to be condition A in order for us to see condition B. This is most commonly expressed as if, then. Okay, if smoke, then fire. All right, that is your most common way of communicating or expressing a major premise. Okay, if you turn in your homework, that is what we call the antecedent, okay? If you turn your homework in late, let's word it correctly, okay? If you turn your homework in late, okay, then you will get a bad grade. Antecedent, if, consequence, then, okay? If A happens, then B will happen. And these are our antecedent and consequent, a contingent major premise, where we do not expect to see B except where we see A. If the antecedent, then the consequent. Now, it is important to remember that this is one single sentence, and therefore this is not a syllogism. One of the most commonly missed questions on final exams, midterm exams, things like that, is if I say something like, give me an example of a hypothetical syllogism. And then someone will write, if there's smoke, then there's fire, period. And then they move on to the next question. And they will then be shocked when they get it 100% wrong. 0 points, no credit. Because remember, a syllogism is always 3 sentences, and this is but one premise, okay? We haven't concluded anything. However, if we establish now, and remember, okay, this is an assumption about the world, all right? This is something that can be observed, okay? We can observe the timestamp on when the homework came in, and we will know whether it came in on time or not. This is a fact claim that can be verified. So we now have 2 things, all right, that fall into the world of known. And we can now conclude, right, following this second premise, we can put in our third premise, the conclusion. A syllogism, remember, must include all 3 parts. So hypothetical syllogism is a major premise that is contingent, followed by usually an empirical fact claim, not always, but very often an empirical fact claim, followed up by our conclusion. The third variation on the syllogism that we're going to look at, and probably our third most common, categorical first, hypothetical second, and then coming in third, is the disjunctive syllogism. Sometimes you'll hear people call this an alternative syllogism, and if you're a student of logic, you'll point out that there's a difference between the 2 of them, and yeah, we can talk about that. Let's keep it simple, okay? A disjunctive syllogism is an either-or syllogism. So instead of a contingent major premise, a disjunctive syllogism has a disjunctive or either or major premise. Let me give you an example, okay? All right, there was 1 piece of pie left and there's only 2 possible beings who could have eaten it. It was either me or it was my dog Lucy, because we were the only ones in the house, right? And I know I did not eat that piece of pie, therefore Lucy must have eaten the pie, okay? There is no other conclusion. Now, keep in mind, there's got to be 3 statements, okay? If I ask you on a quiz or on an exam, give me an example of a hypothetical syllogism, and you write just either or, just the major premise, you're going to get it wrong. So there's 3 statements. Now, one of the things that makes disjunctive syllogisms different from the other 2, one of the unique things that we can do with a disjunctive syllogism is that we can reason in 2 different directions using this, okay? So the idea behind this and what makes these 2 things disjunctive is that it must be one or the other, and it cannot be both. It also cannot be neither, right? It must be one, it cannot be both. It cannot be, if it's one, it cannot be the other then, right? Okay, this is what makes it disjunctive. Now, if there is a third option, okay, if Lucy and I were not the only 2 in the house, if my son Alex was floating around here too, then this is not a disjunctive syllogism, okay? It is invalid because this is a false disjunction on its face, right? That's not true. You maybe need to go back. Remember, we talked a little bit about the law of identity earlier on. You may want to go back and look at the law of the excluded middle. Okay, so now, okay, is it possible that we shared the pie, right? Yes, the dog and I might share a piece of pie. Okay, I'd have one piece and she has another piece, or possibly I ate the first bite of it and then she stole the rest off the plate. Those are both possible. But if they're possible, then we have a false disjunction and our syllogism is no longer a sound syllogism. It doesn't work anymore, all right? The contingent premise only works if our A and our B, Lucy and I, we are genuinely disjunctive in this case. If there's a third option or an overlap between them, then this is not a disjunctive syllogism. Now, here's what's cool then. If the minor premise, the fact claim that I did not eat the pie is negative, then the conclusion must be an affirmative, right? Okay, if the premise is negative, then the conclusion must be affirmative. And it works the other way. If the premise is affirmative, then the conclusion must be negative. So we can flip both of those, right? So if it's me, then it is not her. If it's not her, then it has to be me. So that's one of the unique things that we can do with a disjunctive syllogism that we can't do with the other one. In fact, you try that with a hypothetical syllogism, you can't reason from the consequent to the antecedent in a hypothetical syllogism. That's a fallacy. That's affirming the consequent. You should definitely read about that in chapter 6. We're going to do a quick review on this lecture. We've probably gone on about 45 minutes now. All right, and here's the idea, okay? Remember from chapter 6, okay? Logic, deductive logic. Read that section. Know what the 3 types of syllogism are. That's important. And it's important when you go to take the quiz for this unit that you be prepared to differentiate and say, this is hypothetical, this is categorical, this is disjunctive. Like, you should know the distinctions between those. I did not talk about in this lecture, but I expect you to know on your quiz or for a final exam, midterm, something like that, you should know the difference between a major term, a minor term, and a mediating term. You should, if given a syllogism, you should be able to identify which of the terms is the major, which is the minor, and which is the mediating. Same thing. You should know the difference between a major premise, a minor premise, and a conclusion. If you're given a syllogism, a disjunctive syllogism, a categorical syllogism, a hypothetical syllogism, and asked, identify the minor premise, you should be able to do that. You're going to need to read chapter 7 in your textbook. So keep in mind, you've got other lectures coming, other lectures that are posted on inductive reasoning and on fallacies and evaluating logic. So remember, chapter 7 is a big one. This lecture just covers a small part of it. I hope you found it useful and I hope it added to what you're already learning.